Assalamualaikum warahmatullahi wabarakatuh. My name is Ramsa bin Alam and I will present about our project introduction. First of all, structure refers to a connected body or system of parts that are used to carry a load. Building, bridge and towers are example of civil engineering. Ship and aircraft frames, tanks, pressure vessel, mechanical system and electrical support structures are example of other engineering areas. A structural system is a combination of the structural element and their material. A structural engineer must be able to classify a structure by knowing the various elements that make up that structure, whether by form or function. The design of a truss makes it possible to analyze the structure using a few hypotheses and apply the laws of motion of Newton in accordance with the branch of physics known as statics. For research purpose, where the straight component cross truss are considered to be pin joint. On application of load on the truss joint, force are communicated to the truss element. Still, truss bridge members are in compression or tension. The truss possesses a high ratio of strength to weight and therefore are useful for being employed in truss bridge. This project is performed to apply the theories and formulas that we have studied in practice in real life. Furthermore, through understanding the tensile and the compression strength of construction materials force distribution in a truss, the project allows us to gain a deeper understanding of the building structure. There are four types of truss bridge. Firstly is hoe truss. The hoe truss consists of diagonal and vertical elements. The diagonal elements slope toward the bridge center in an upward direction. The vertical elements are under tension. This is a rare type of truss bridge originally patented in 1840 by William Howe. And secondly is a Bailey bridge. This bridge is normally utilized to cover obstacle by the military tank and other equipment. It can be constructed without the need of heavy tools or machinery. And then K-truss. The bridge design is complex and the construction requires extensive use of heavy equipment. The bridge element under tension are reduced in a number. And the last one is bowstring arch truss. This bridge was patented in 1840 by S. Whipple. The main characteristic here is that the vertical load on the truss arch are transmitted along the arch path. At the end of the arch, the truss is resolved into vertical and horizontal component.
Assalamualaikum and hi, I'm Rabiatul Adawiyah binti Nazri. My metric number is CF 2017. I will continue this presentation with chapter 2, part 1, design and layout. The truss bridge that we design is Warren truss bridge with vertical. This is the flow chart that we start. Before we start, we do some research about the component of a truss bridge and learn the types and study fundamental structure engineering concept like force, load, reaction, equilibrium, tension, compression and strength. We start with propose the bridge layout and design based on existing bridge. After approved by our lecturer, we declare the dimension and calculate all direction of the truss bridge. And then we analyze the internal forces and deflection that occur in the truss bridge. Next, we're using manual calculation and Greenbro software. Then both of these methods we compare and discuss. Okay, this picture shows the two-dimensional truss bridge design, which is in front view. This is two-dimensional truss bridge without load, and this is two-dimensional truss bridge design with 100 kN load respectively at point H and I, 50 kN and 50 kN. In most trusses, we know that members are arranged in interconnected triangles as shown. Because of this configuration, truss members carry load primarily in tension and compression. We choose project design characteristic. Why we choose Warren Truss? Because it perhaps the most common truss for both simple and continuous trusses. Warren Truss also strong because it uses equilateral triangles to split out the load on the bridge. The equilateral triangles minimize the forces to only compression and tension. Interestingly, as a load such as a car or train move across the bridge, sometimes the force for a member switch from compression to tension. This happens especially to the member that near the center of the bridge. The advantage of a Warren Truss also gives ability to split the load evenly across a number of different members. Therefore, the Warren Truss is more advantageous for span load but not suitable when the load is concentrated at a single point or not. However, the effect of several deflection of Warren Truss will occur, such as truss structure will undergo concentrate force under a point load. Under this concentrate load scenarios, the structure is not as good at distributing the load evenly across its members.
Assalamualaikum. I will continue explain about part 2, which is analysis of trusses. So there are two methods that will be used, which is manual and software. First, we go through the internal forces on truss. The calculation of internal forces is calculated manually by using method of joint. So all the joint in the trusses is involved in the calculation. You can see the result of internal forces in the below of this slide. Our group calculate joint from A, C, D and H. Then due to the symmetry, the right side of the trusses will get the same value of forces as the left side. So the positive value will refer to the tension and negative value will refer to the compression. Next, internal forces on truss by using reinforced software. In this slide, you can see the black box shows the diagram of internal forces. There is a little bit of difference to manual calculation, so the value of software calculation is greater than manual. By using method of joint, the greater value different force member obtained is 3.7 kN, which is on member CH and GI, while the smaller value different of force member obtained is 0.2 kN, which on member AH and IB. All the members you can see in the white box in this slide. Next, in order to find deflection, the new internal forces on truss is calculated. So the calculation of internal new forces is calculated manually by using virtual force method, which is 1 unit load is applied on joint E. So the procedure of finding and calculate the forces is same as before. The positive value will refer to tension and negative value will refer to the compression. So you can see the result of internal new forces in the below of this slide. Next, we go to the calculation of deflection by manual. So our group construct this table to easier to find F, mu, L, which L refer to the length, F refer to the F, and mu refer to the new internal forces. So we use the total number of F, mu, L and put it in the formula. The formula you can see here in this slide. For A, which is area, we assume as 0.008 m square and elasticity as shown in this slide. And we put all the data in the formula and we got the deflection is 0.007515 meter. Next, the deflection on truss by using reinforced software. You can see here in this slide shows the diagram of deflection of our truss. So the value of software calculation is smaller than manual. By using visual forces method, the deflection value obtained is 0.07515 meter, while by using software we get the value of 0.000074 meter, as there is a different value which is 0.00666 meter.
In conclusion, we were able to determine and investigate the theoretical link between the measured forces in a loaded, redundant truss, which was the purpose of this experiment. The alternative method and the section method are both used to determine the forces acting on a member, which is called cut section. These forces can be calculated in each joint and member of the system. We must ensure that the design is appropriate, safe and cost-effective, as well as having its own aesthetic value in order for it to appear more unique while maintaining high safety.